systems. And here in this lecture, at the beginning, at the end, or the rest of this lecture, just I want to show you something we might or explain some examples from the material that you'll study. Okay, so the main goal, يا شباب, of this course is to help the student to understand the topic. From understand this topic, the student will be able to model. That means, as we said, the model is to get the mathematical equation to model the system. That means we get a mathematical model from electric circuits or mechanical systems and analyze this system. What we mean by analyze the system? Is the system stable? Is the system useful or unuseful? Is the system affected by unwanted signals? Okay. How we attenuate these effects, how we eliminate these effects, all these things we'll study, inshallah. And at the end, we went chapter 9, we will design a linear control system like PID control or PI control to enhance the performance of this system. Okay, so you'll work to enhance the performance of this system based on our goals. These things we will cover. So here, chapter 1, as we said, introduction. Chapter 2, the modeling will start with translation mechanical, and after that, electric circuits. Okay. This is example how we get the model. So here, for example, this will be chapter 2. Here we have to model EE, electrical circuits, or ME, mechanical systems. Okay. So here usually we have some question like this one. Here we give you, for example, electric circuits like this one. You are free here to get the model. If you are familiar with Kirchhoff voltage law, or you want to apply Kirchhoff current law, or we called it, for example, mesh analyze or nodal analyze, super mesh, super node, any method that you studied before, or the skills that you have it. Inshallah, we will review this during the lecture. All this method we'll review it for 2 lectures. And we will have plenty of examples. No need to go for more resources. What we have in the lecture, I think, will be enough for you to solve the problem that will come in the exam. Okay, so for example, we have system like this one. We might use Kirchhoff current law because I have here I source is equal R1 plus IR plus IL plus IC. After that, I will apply or substitute, and instead of the value of ice by it is from Kirchhoff law. So after that, I might get equation. So the equation here that I have it, IT is equal IR plus IL plus IC. Okay, so after that, I want to complete the equation. And mechanical systems, usually it comes like this one. We apply Kirchhoff second law, or we need to apply D'Albert law for the mass. So here, if we have a mass, usually we are interested to compute the displacement that we have it here. You can see this is the displacement or the variable x. Okay, we have variable x here, you can see. So our concern usually is to compute the displacement x or the output. We called it here the output. The input force, هذا الانput force, or the force that's applied to the mass, that will make this mass accelerate in this direction with displacement equal x. If I apply force on this mass, so this mass will get some acceleration, but this acceleration will affect by different factors. We have here the spring stiffness effect, because as we know, if we have a spring like this one. Okay, if we have a spring, let's bring a pencil. If I have a spring like this one, okay, if I try to extend the spring, I pull the spring in this direction. Okay, so now I extend the spring to these strings. Okay, you can see this is the normal length of x, and now this is the new x or displacement that is spring it. Okay, so from this area, from here to this point. Okay, this is the displacement or the new displacement the spring get. What will happen to this spring if I realize my hand now? If I pull this one now from here to this one, if I realize this spring, what will happen? يعني أنا في البداية سحبت السبرينج بكل قوة. أوكي، سحبت السبرينج، سويت أبلاي عليه فورس. هذا سبرينج هو مثبت هنا. Fixed at this
It's back to his size, his original size.
Yes. Okay. This is the spring. It is normal length is L. This is the length. And now, if I apply force, the length now becomes L plus X, the new length. Okay. So I pull it to this point. سحب عليها. If I realize this one, okay, the force that mean equals 0. So this spring will return back to this direction because the spring will try to return back to its normal shape. We call this the stiffness force. So in the system here, you can see if we apply force on this mass, the mass will try to move in this direction. But because of the spring try to return back to its normal shape, so the spring will work in the opposite direction of this motion. Okay, so the spring will work in the opposite direction. The same things for the fraction. هذا الفراكشن fraction هو الاحتكاك. Okay, fraction, the same things like the spring, but here this will be in terms of displacement and this will be in terms of velocity. Also, we have the weight of the mass. The weight of the mass also we have or acceleration of the mass itself. Okay, if we try to push a small system, if I use the same power, for example, to push, for example, small system or small mass, and also I use the same power to push a large mass. So the larger mass will move slowly or less than the small mass because of the weight of this mass. Okay, so this also will have an opposite effect on the acceleration. Okay, so all these things inshallah will study in chapter 2. This is what we do. Here we'll use the elements laws for the currents. As we know, the currents through the index resistance is equal voltage over resistance, and other things. All these things inshallah we'll cover. So this is the example, as we said, the previous example that we show. So by using Kirchhoff current law, I have IO or IT is equal IC plus IL plus IR. This is the equation. This is the model equation, but we try to complete it. What's IR? The current through the capacitor, the resistance. I get it from here. This is IR is equal voltage over resistance. Okay, so this is equal voltage over resistance. IL, I will get it from here. IL, this one, IL will be integration. So in the exam, I will give you this one, the elements law, to solve this problem. So after that, we substitute instead of any current by its correct value, like this one. And this will be هذا نسميه الموديل يا شباب. هذا الموديل. هذا السوليوشن للبروبلم. This is the model of these circuits. Okay, so by applying Kirchhoff current law, I get the model, and this is the equation of the model. Sometimes we need to simplify the problem more by taking the derivative because I want to eliminate the integration here. I might take derivative with respect to time to solve this one. Okay, we take 1 second derivative, so we have another solution. So this will be the model. Until here, you will get full mark. Okay, so this is what we mean by the model. This will study it in chapter 2. This is also for mechanical systems like this one. We compute also the forces and the elements law for the mechanical system. For Laplace transform, after we get this equation, as we said, if we get this equation, now this equation, you can see this is derivative with respect to time, second derivative. how we solve these problems, how we solve this equation, because a solution of this one, that means I want to compute the value of x, or in this equation is the value of v. So here we will use Laplace transform. What's the Laplace transform? Laplace transform is just a tool that helps us to solve the problem in 2 steps by converting the differential equation that's in time domain. Actually, this time domain. Okay, this time domain, let's convert the problem of or the equation from time domain to frequency domain. If I convert time domain to frequency domain using Laplace, that means I will convert the complex problem differential equation. I will get algebraic equation now. Okay, so this will give me algebraic equation. A solution to the algebraic equation is very easy. We just do manipulation. After that, I compute it. Okay, so this is the algebraic equation. The parameter or interesting of x of s now. So usually we use capitals to represent the Laplace x capital now of s. We call this s domain or frequency domain. And after that, I will solve the problem. A solution, that means I want to compute x of s. And it's a solution. This is the solution of the algebraic equation. Then now this solution now in frequency domain, but I want the solution, I want to have the solution in time domain. What I will do, I will apply inverse Laplace. Okay, I will apply inverse Laplace. Inverse Laplace, otherwise I can apply inverse Laplace directly from the table, or we will use partial fraction. Okay, partial fraction. You are familiar with this, I think. You use different techniques before. Any technique you use it to get the solution. So here that I have it x of s, I will apply partial fraction or inverse Laplace from the table to get the solution. Now this is the solution of the algebraic equation, and this is the solution of the original differential equation in time domain. So instead to have direct solution of this problem, and usually this is difficult, differential equation, we'll use the Laplace transform as a step to avoid the direct solution. This will help us to simplify the problem from differential equation to algebraic equation, and then we find the solution of the algebraic equation. We apply inverse Laplace to return the problem from frequency domain. Now this is S frequency domain to time domain. Okay, to time domain, and this will be the solution of our problems. And this is the objective of chapter 3. These 2 steps. Okay, chapter 3, and we'll work more in this chapter, inshallah. Why Laplace transform? Because we use Laplace to transform the problem from difficult version to easier way to solve it. Example of Laplace transform is like this one. If you want to compute this problem, the multiplication of this problem, a is equal 3 terms, multiplication of 3 terms, someone might use logo or logarithms here. And logarithms will help us to convert the multiplication to sum. Okay, so here what we do, so logo of a is equal logo of this term plus logo of this term plus logo of this term, and this is equal this one. So now I convert logarithm or the problem from complex one, that's mean multiplication, to a simple one is sum. After that, in the Laplace, we use inverse Laplace because we want to get the solution for the original problem. Here also, we apply the inverse of the logo. The inverse of the logo is the exponential. Okay, so I apply exponential here, this inverse of the logo, and we get the solution of the original problem. Okay, so the Laplace transform, it does the same things. That help us to solve complex problem, differential equation or ODE differential equation without the need of direct solution of this problem. We convert differential equation to algebraic equation, and then we get the solution of the algebraic equation. This will be the solution of the algebraic equation. And after that, we apply inverse Laplace to get the solution of the original problem. Okay, and this is the table we usually give in the exam. This represents the Laplace of different or famous signals. We have different systems or signals, or we have it here. The first one we call this impulse signal. We call this step signals. Let's type this one. Later I will type this. هذا الامبلس، هذا ستيب نسميها unit step or step function. هذا الرامp function. You know this one, this exponential. This is ramp multiplied by exponential. This is cosine, sine, exponential multiplied by sine, exponential multiplied by cosine, and time square. Okay, so all these things, inshallah, you should know. This table, this will give in the exam, but if you recognize the Laplace of these functions, the basic functions, this will help you to solve the problem faster. No need to check the Laplace of these things during the exam. You should memorize these things. Very easy. And this not this only Laplace, I will give you more than this table during the exam. Okay, and this is the partial fraction that we use it to obtain the inverse Laplace. Okay, partial fraction expansion. Okay, inshallah, next lecture we'll start from here. Talk about what we have here, and this is the block diagram reduction, and what we'll have in the lecture. And next lecture, inshallah, we'll try to focus. I will take 15 minutes or 20 minutes to explore the course, and after that I will start the topic, introduction to the control system, and the definition and others. Inshallah, I will submit this handout inshallah later on the blackboard to read and to follow the class step by step. Any question?